Okay, so today's lesson, guys, is 7.2 part 1, and we're solving exponential equations. Okay, 7.2 part 1. We're going to solve exponential equations. And so you guys can imagine then what our objective is. Our objective is solving exponential equations. That's what I want you guys to be able to do by the end of this. Guys, there are these exponential equations that we're going to solve that are a little bit simpler. Later on in the chapter, we're going to solve exponential equations where you have to use logarithms. So they're a little more complex. Actually, they tend to solve pretty easy with logarithms. But this is kind of the intro to an exponential equation. Okay. So in an exponential equation, if you guys want a kind of definition, equation, variables occur as exponents. Okay. And what we're going to use to solve this is it's the property, it's kind of lengthy here, of equality for exponential, holy cow, it is lengthy, functions. Property of equality for exponential functions. And let me give you this in words. This is my fancy version of it, and then I'll give you a simplified version of it. Okay, so it states let b be greater than 0 and not equal to 1. So b is positive, it's not equal to 1. Okay, then b to the power of x equals b to the power of y if and only if x is equal to y. Okay? Some base to the power of x equals that base to the power of y if and only if the exponents x and y are the same, or they are equal. Okay? So an example, okay, 3 to the power of x, let's say if 3 to the power of x equals 3 to the power of 5, then x must be equal to 5. And in the other direction, if x equals 5, then 3 to the x equals 3 to the 5. Okay? And so we're going to use that property to help us solve exponential equations. So the first example, two to the power of 2x equals 2 to the power of 4. Okay? So we're able to say that 2x must equal the other exponent, 4. X must equal 2. That is our solution. Easy enough? Okay. It'll get a little more complicated, but that is the basics of it. Okay. That's the simplest application of the property. So let's do another easy example here. 3 to the power of 2x plus 1 equals 3 to the 7. I want to solve this equation for x. Guys, are the bases the same? So the exponents must be equal. So solving a linear equation, subtract 1.
So the degrees cancel out then?
I mean, they are part of the equation, but essentially, yeah. If we have the same base, which we do, then we set the exponents equal to each other. Yep. They're not really a factor in the problem after we have the same base. Okay. But as you guys will see in the next example, we don't always have the same base. Okay. These first two, we had the same base, so we didn't have to worry about the exponents. Or sorry, we didn't have to worry about the bases. Okay. Questions on either of those first two examples? Guys, most of the problems on the homework are going to be of this next variety. Okay. What if the base is not the same? Okay. I want you to remember one thing. This is properties of exponents. I know we reviewed this a little bit last week. This is just kind of a reminder. If I had 2 to the power of 2, and I wanted to take that to a power of 4, we take a power to a power, we have to multiply the exponents. So this is like 2 to the power of 8, right? We're going to multiply the exponents, 2 times 4. So keep that in mind as we solve these equations. We're going to be applying that property pretty frequently. Okay. So the first example where the bases are not the same. Okay. We can't just say x equals 3 because the bases are not the same. However, 8, you can change the base. Okay. So the left side we're going to leave alone. 8 we can write as base 2, right? 2 to the power of 3 is equal to 8. Shake or nod as if you understand the words coming out of my mouth. Okay. 8 is equal to 2 to the power of 3. Yes? Okay. So we're changing 8 to base 2. This left side of the, or sorry, this right side of the equation, if we take a power to a power, we multiply the exponents. Three times 3 is 9, so x must be equal to 9. Any questions on this property? This is the, or on this problem. This is the kind of the easiest first example of this. So does everybody understand what happened there? Okay. We'll do another example like this. So if we have 9 to the power of 2x minus 1, let's say that is equal to 3 to the power of 6x. As the bases aren't the same here, what side should we change the base on? So 3, we could not write as anything other than 3, right? It's 3 to the power of 1. It's already its simplest base. Okay. 9, well, that's 9 to the power of 1, but we could also write 9 as 3 to the power of 2. We can change this left side. We changed it to base 3. When we do that, I talked about we have to multiply the exponents. So this left side, we have to distribute the 2. We have to distribute the 2. From there, once they're both base 3, we can set the exponents equal to each other. About questions there? Do what?
That seems pretty easy.
Seems pretty easy. Let me throw one that maybe is tougher. It's not initially in my example, so this might work out to be a fraction, which is fine. I'm just going to try to make up an equation off the top of my head because I don't have an example like this, but it's something that could come up, and I want you guys to be prepared for it. So we'll try to keep it somewhat simple, but maybe a little more complicated as well. All right, if we started with something like this, I don't know how the equation is going to work out. It might get a little ugly, but it's a valuable example. So you guys tell me why this would be a valuable example. What's maybe tougher about this one? Okay. The last two examples, we only changed one base, right? We took 8, we changed it to base 2. The other side was already base 2. Here we took the left side, the right side was already base 3, and we could change 9 to base 3. 8 you cannot change to base 4. It's not because 4 squared is 16, right? So we can't take 8 and write it as 4 to the power of anything. And we can't take 4 and write it as 8 to the power of anything. Okay. Both of these you could write as base 2 though. 4 is 2 to the power of what? 2 squared, right? 4 is 2 squared. 8 is 2 to the power of 3. 2 times 2 times 2. So here you had to change both bases. I'm not sure how the algebra is going to work out with me just making up the equations, but we got 2 times x plus 1 equals 3 times 2x minus 1. Just got to do the distributive property here. Last time I did that in the exponents. Here I'm doing it in the equations. It doesn't matter either way. It's not too ugly. 5/4. questions? You guys are good to go on this? We understanding it? Okay. Let's practice a couple. Take a few minutes here and practice these on your own. These are more similar. This one, you only need to change the base on one side of the equation. You don't have to change. It's not like that last problem I just showed you. This, you only need to change one of the sides.
So you have to get 64 to be the same as. And to be 4.
Yeah, you want to change 64 to base 4. That's exactly right. So 64 would be 4 to the power of what? And this you can check on a calculator, but just how many times do you have to multiply 4 by itself to get 64? So 4 times 4 is 16. What's 16 times 4? So 3 times, right? 3 factors of 4.
So you take 4 to
So 64 is,
4. So that's what you have to find out to get to be.
yep, that's what you got to find out how you can change one of the bases here.
I found the answers.
Adam, you got both the answers?
Yeah.
Excellent. Oh, I'm going to turn up the volume here. Adam, what'd you get on this first one?
X equals 16.
16? Wait a second. Did you have 4 to the power of 2n minus 1 equals 4 to the third?
No.
You did not get to this point?
Mm-mm.
So recall, we want to make sure that they both have the same base before we start. Once you have them to have the same base, so what we were doing here in class, I'm not sure if you overheard us, we were talking about, okay, 64 equals 4 to the power of 3. Okay. And so once we knew that, we wrote it as 4 to the power of 3 because now once the bases are the same, we can set those exponents equal to each other. And so when we solve this, I think for the first one, what, we get 2, right? N equals 2. Has anybody solved the second one yet? Take another minute or two, guys. This is our last couple of examples, then we're going to start on the homework. So let's take another minute or two and maybe solve this last one. The 125, that's obviously that's the one we're wanting to change to base 5. Yeah. Yeah. Just as a kind of a guide, you should end up with x equals 3. If we're not getting to that point, then we've made an error somewhere, okay? Marquise, were you able to sort out how you change 125 to base 5? Not sure on that one yet. Emily? 5 to the 3rd? Emily, will you try to explain to me how, because obviously some people, we're going to struggle. That's going to be the hardest part if we can't get that to be 5 to the 3rd. How do you explain 125 is 5 to the power of 3? How does that make sense to you? Just as many times as it took to get to 125 because you knew it had to go to base 5? Okay. It worked, obviously. Anybody else have any helpful tips maybe on how to understand that change in the base? Because that's obviously the hardest part, guys. Solving linear equations is not hard for Algebra 2 students. That's easy. The hard part of these are making the bases the same. Okay. So, but no, that's spot on. It's 5 to the 3rd, so we got to distribute that exponent. We got what? 3x plus 6. Subtract 3x. That gives, oh, those don't cancel, sorry. Those cancel. That gives us 2x equals 6. Divide by 2. X equals 3. Okay. It might be helpful if you're struggling. So Emily was just saying she just did this. She just multiplied 5 by itself as many times as it took. She got 25 and said, okay, times 5. Oh, well, that's 125. That's 5 to the 3rd. Okay. If you're someone who struggles with that idea, you could probably use a calculator and just maybe get those first few integers out to the couple different powers. So like 5 squared is 25, 5 to the 3rd, 125, 5 to the 4th, 625. Okay. And then you might do the same thing with 2. Okay, 2 to the 1st is 2. 2 squared is 4. 2 to the 3rd is 8. Okay, and take it out a few just so that you can understand. Maybe do the same with 3 and 4. Might be helpful. Okay? Any questions before you guys get started on homework?
There's a lot of time today.
Maybe we should have done both parts of the lesson. Okay. Got about 13
I
minutes
have
left.
one.
Oh, Adam, what's your question, bud?
Since I won't be here tomorrow, how will I retake the test?
You mean since you won't be in attendance at school?
Mm-hmm.
Good question. I didn't think about that with being hybrid. Or Wednesday morning. I'm not going to do Tuesday because that's going to be the very first day of the week. Wednesday morning, the cohort B, because this is cohort A, right? Cohort B, Wednesday morning, 7 a.m. or Wednesday afternoon, 3 to 3:45.
Okay.
So I'll make an announcement so I can post that so it's clear for everybody. So Nathan, I know you're on here. You're hearing that. Is that making sense to you?
Yeah.
Okay. So rather than doing that tomorrow morning, we'll wait until a day you guys are actually coming to school. Any other questions? All right. Thanks for joining me, guys, from home. You guys can go. I'm going to go ahead and end the Zoom, actually. So.